So in this class, we are going to learn about optimal binary search tree problems. So already we know optimal binary search tree. So if they are giving some elements, okay. So how to construct the optimal binary search tree? We already know how to construct binary search tree. Compared to root node, left side is less value and right side is more value. Okay, that is binary search tree. And optimal binary search tree means for given value, okay, there are so many binary search tree we are going to construct. Okay, that is how many binary search tree it is possible to construct. There is the formula 2n c n plus 1 by n plus 1. Okay, that is we already know that. From the number of binary search tree, okay, which binary tree is best and it gives the optimal solution for searching all the elements. Okay, that binary search tree is the optimal binary search tree. So now directly if they are given that elements, how we are going to construct the optimal binary search tree? Okay, that is the problem. Okay, optimal binary search tree problem. How we are going to solve this problem? Okay, optimal binary search tree. Okay, so it has the formula that is, please, this is the formula. All of you remember this formula. C of I comma j equal to C of I comma k minus 1 plus C of k plus 1 comma j plus probability S equal to I to j ps. Ps is the probability. Please remember this formula. We are using this formula and we are going to solve that. We are going to construct the optimal binary search tree. Okay, so the problem is do if int while. So these are the elements. Instead of sometimes they are giving elements 5, 6, 7, 2 like that. So do if int while. By using these elements, we are going to construct the optimal binary search tree. Okay. For that, solving this problem, they are giving the probability. The probabilities are 0.1, 0.2, 0.4, 0.3. Okay, totally 4 elements, 4 probabilities they are given. Okay, so now we are going to construct that binary tree for this elements. Do if into while. Okay, how do? Okay, let's see that process. Please remember that formula. Okay. So this is the formula, this is the problem. So for that problem, we are going to write the probability one by one. Okay, we are writing the probability that is 0.1, 0.2, 0.3, 0.4. So we are assigning it is 1, it is 2, and this is 3, this is 4. Okay. That is up to 4 values. So A of I equal to 1, 2, 1, 2, 3, 4. So P of j equal to I equal to that probability 0.1, 0.2, 0.4, 0.3. Okay, so that is the problem. So now let's see how to solve this one. Okay, we are going to construct 2 tables. Okay, one is called cost table. One is called cost table. Another one is called root table. Okay, 2 tables we are going to construct. So first one, how to construct the cost table. Okay, so for that, first how many number of elements, that is 0 to n we have to mention in that row wise. 0 to n. So 0 to n. So how many elements? 4 elements. So 0 to 4 elements. So 0, 1, 2, 3, 4. Okay, 4 elements we are going to construct. Okay. Please listen carefully how I am going to construct that. Zero, 1, 2, 3, 4. Okay, it is 0. And in column wise, it is I2 n minus 1. I2 n minus 1. I2 n plus 1. Sorry, n plus 1. So I initially it is 1. So 1 to n plus 1. That is n is how much? 4. 4 plus 1, 5. So up to 5 you must write is 1, 2, 3, 4. Okay, 5. So here it is 0, 1, 2, 3, 4. Okay. Now we are going to construct. So how to construct that cost table? So 5 means initially you have to draw like that. Okay, for 3 from here to okay 4 and so that is the table we are drawn here. Okay, so next we have to fill the columns. Okay, how can you fill the columns? Initially that diagonal first column and row all are it should be 0. It is common to all problems. All are it should be 0. And we know the probability in the table problems. So what is the probability? First one 0.1. Yes. The second one is 0.2. The third is 0.4. Okay. And fourth one is 0.3. So that is the probability we are taken from the problem. Now our aim is to fill these empty rows and columns. These cells we need to fill it. For filling this one, we are using that formula. Okay, C of I comma j equal to C of I comma k plus 1 comma C of k minus 1 comma j plus probability of TS. Okay, that is the formula we are going to. So now I think you are understanding about how to construct the cost table. Yes. Okay. Let's see. Next, how to construct the root table. Okay. How to construct that root table. So for that, so how many elements totally? 4 elements. Yes. So for 4 elements, we have to draw the diagrams. That is 1, 2, 3, 4. Okay. What is this? 1, 2, 3, 4. So in vertical also write 1, 2, 3, 4. So 3 elements. So we are going to construct 1 to 4. Okay. So we are divided into 2 parts. This is 1. We are divided. Okay. Now let's see about how to construct root table. So for that, similar to cost table, that So for 3, okay, for 4, okay. So now, so how many number of elements? 1 to 4. So in that initially we have to write 1, 2, 3, 4. Okay. So the remaining cells we have to find out the answer from the problem, from the equation. Okay. So from the formula. So remember this one. Okay. Hello. Is it audible? Yes.
Yes, sir. Yes, sir.
Hello. Is my voice is audible?
Yes, sir.
Please reply any one of them.
Yes, sir.
Okay, thank you. So here, this is the root table. So these values and these values we are going to find from that formula. Okay, how to do this one. Okay, so now we are going to find the probability. So what are that values we have to find here? That is C of, this is I, this is J, 1, 2. Okay, C of 1, 2, we need to find. Next, C of 1, 3. Okay, C of 1, 3, this value. Next, C of 1, 4. Next, C of 2, 3. Next, this one 2, 4. First you take I value, then J value. Next, this is C of 3, 4. Okay. Okay. So that is I am writing here. Okay. These values we are going to find C of 1, 2. Okay. This is C of 1, 3. Okay. 1, 4, 2, 3, 2, 4. And this is 3, 4. Actually, this is 3, 4. Okay. This one. Okay. So now it is the I value. Okay. It is J value. First you take the first one, C of 1, 2. Okay. Listen carefully. I'm going to solve one. So remaining thing you only going to solve and tell me the answer. Okay. So now you take 1, 2. So what is the formula? So you know the formula, C of I comma K minus 1 plus C of K plus 1 comma J plus the probability summation of I equal to 1 to that is I to J PS. Okay. The first one is C of 1 comma 2. So 1 is the I, second 2 is the J. So I 1 comma 2. So 1 comma 2 means we have only 2 elements. Okay, 1 and 2. So the K value it should be 1, either 1 or 2. Okay, first you submit K equal to 1. Suppose C of 1 comma 3. 1 comma 3 means what? That is the K value it should be 1, 2, 3. Okay, 3 values. K equal to 1, 2, 3. 1 comma 3. Suppose K 1 comma 4 means 1, 2, 3 comma 4 K values. Okay. So I think you understand about how to find k values. So here 1 comma 2. So k value is 1 or 2. Okay, 1 comma 3 means 1, 2 and 3. 1 comma 4 means 1, 2, 3 and 4. Okay. So now 1 comma 2. So 1 and 2. Now first you substitute k equal to 1. So I comma j. I is 1. J is 2. C of 1 comma 2. So C of first one I. What is I? 1. Okay. K minus 1. K is 1. So 1 minus 1, 0. Plus C of K plus 1. K is 1. Okay. First it substitute K equal to 1. Then next time we will substitute K equal to 2. Now K equal to 2. 1. So 1 plus 1, 2. And J is what? 2 only. So it is 2. Plus summation of I 1 to J 2. 1 to 2. Okay, 1 to 2 means what? There are two probability. Two probabilities. One is P of 1 plus P of 2. Okay, if it is 3, P of 1 plus P of 2 plus P of 3. So 1 to 2 means 2 probability P of 1 plus P of 2. Okay. So now let's see from the table what is 1 comma 0 answer. You check in that cost table what is 1 comma 0. So we already know the table. Yes. So from the table 1 0, what is the answer? 0. So C of 1 comma 0 is 0. 1 comma next 2 comma 2. So 2 comma 2, what is the answer? 0.2. So 0.2. Okay. Next one, summation of P of 1 plus 2. So probability of 1 and 2. So we already know from that given problem, we have 4 probability they are given. So P of 1 is what? 0.1 plus P of 2 is what? 0.2. Okay, from the given problem, probability, 4 probabilities they are given. That is also we are written here one by one. Yes, 0.3. This is fourth one, 0.3. So 0.1 plus 0.2, what is that? 0.3. So here 2 comma 2 is 0.2. Okay. And the probability you add 0.3. 0.1 plus 0.2, 0.3. So totally how much? 0.7. So now we are finding the value is 0.7. Okay. Sorry. C of 2 comma 2 is 0.1. So it is 0.2. So totally see. Sorry, here see that C of 1 comma 0. 1 comma 0 is 0. Okay. 2 comma 2. 2 comma 2 is 0.2. Okay. And next this one, what is P of 1? 0.1. It is 0.2. So totally 0.3. So 0 plus 0.2 plus 0.3. So totally what is that? 0.5. So C of 1 comma 2 have the value is 0.5. 0.5. So now K equal to 2. Okay, now we are substituting K equal to 2. So similar to same formula, C of I comma K plus K minus 1, that is 2 minus 1, 1 plus C of K plus 1, 2 plus 1 is 3. J is 2. Okay, P of 1 and P of 2 we already know 0.2. That is the 1 comma 1 from the table 0.1. 3 comma 2 is 0. And P of 1 plus P of 2 is 0.1 plus 0.2, that is totally 0.4. Okay. Now, please listen carefully. 1 comma 2 for K equal to 2, the value is 0.4. When K equal to 1, okay, K k equal to 1, the value is 0.5. Which is minimum? Which is minimum? 0.4 is minimum. A 0.4 is minimum. When which value we are submitting, the value can get minimum when submitting k equal to 2. K equal to 2, we get that minimum value. So this value we are going to fill in the cost table, and this value we are going to fill in that root table. Okay. This value going to fill in that cost table. This value we are going to fill in that root table. So the next step is we are going to fill that table. Okay. I said no. So when we are submitting C of 1, 2, that is when the value k equal to 2, minimum value, that time we got the minimum value 0.4. We are filled this one. Similar to same, we are applying C of 1, 3. Okay. So for k equal to, what are the values? 1, 2, 3. 3 values. So k equal to 1, submit it. What is the value? K equal to 2, submit it. What is the value? K equal to 3. What is the value? Next 1, 4 means what? What is the k value? Either 1, 2, okay, 3 and 4. So k equal to 1, submit the value, and I equal to 1, j equal to 4. Submit in the formula. K equal to 2, k equal to 3, k equal to 4. Submit in the formula. What is from these 4, which value is minimum? That value 1, 4. We have to fill here minimum value. For which k value it is minimum? That minimum value we have to fill here. Like that, C of 2, 3 and 3, 4. Okay. Please do yourself work out that problem. Okay. So here I will show the answers. When submitting 2, 3, so I equal to 2, j equal to 3, k equal to 2. Okay. First initially submit k equal to 2, next k equal to 3. Okay. So we are getting the answer, and k equal to 2, we are getting the answer is 1. Okay, k equal to 2, answer is 1. Next you submit k equal to 3, that answer is okay. So when we are submitting k equal to 3, we are getting the minimum value, so 0.4. So here 3. Okay. So similar to submit, solve that k equal to 1, 3 means k equal to 1, 2, 3. So find out which is the minimum value. Okay. When submitting k equal to 3, 1.1 is minimum value. K equal to 2 means 1.2. K equal to 1 is 1.5. Okay, it is that. So for this minimum value and 1, 4 means 1, 2, 3, 4. So k equal to 1, k equal to 2, k equal to 3, k equal to 4. Okay. So when submission k equal to 3, it is minimum 1.7. So C of 1, 4, root table is 3, cost table is 1.7. Okay. So finally, we have the conclusion. Okay. So we are filled that all the remaining cells, minimum value. So for this is the k value, it is the minimum. Okay. We are completed cost table and root table. Okay. So now what we are going to do, from the root table, the first one and the last, that is first row, last column, 1, 4. For all that problem, the first row, last column, what is the value? 3. Okay, please remember this one, 3. So this is that root value. Okay, this is the root value. So 3 means here 3, what is 3? That is first row, last column in the root table. It is the root value. Okay, because we are going to construct optimal binary search tree. Yes. So for that, we have to find out the root. Okay. So this is the problem. So this is 1, this is 2, this is 3, this is 4. Okay. So first the root is 3. What is 3? Int. So integer is root. Integer is root node. Next, it is the root node we are founded. For integer, if is left side and while is right side. Okay. So for integer, if is left side and while is right side. Okay. Now we have one more element, do. Where is do? If, for if it is left side. So for if it is left side. Okay. So this is the optimal binary search tree. Okay. This is that optimal binary search tree. Okay. So first you have to find out that cost table and root table. From the root table, the first row, last column, what is the value? 3. So integer is the root. For first you have to find out the root. Okay, from the integer, what is left side? If right side is while, and for if left side is do, so left side is do. So this is the optimal binary search tree for that given problem. Okay. Thank you.